So, on section 3, and this one will be split over 2 days, but for section 3, we're going to be dividing. Now, before I go into actually what your problems are going to look like, I want you to, if I gave you that problem and said you cannot use a calculator, calculator's not required, how do I do it?
Long division.
What's that? Okay. I forgot what long division is, although that's probably how you would do it, but I forgot what to do. So how do you set it up?
You put 3 on the house, and then put 3,478, and then you divide over it like 3. Divide by 3 is 1, and put that on top.
Put what on top? Of where?
1 on top of 3.
1 on top of the 3 like this?
No, but on top of the house.
Oh, you didn't say that. So 1 here?
Yeah. And then 3 doesn't, no, it goes in 4 once, and then you have to put it under, I don't know, traps.
Okay, how do you long divide? So far this is what Vanessa's got me set up with, and now she's confusing herself.
Oh, you do a lot of subtracting, and you take it down, and you add.
I do a lot of subtracting, then I take it down and put other numbers on top. Okay, so it's hard to explain, isn't it? Even though you've started out okay. The divisor goes on the outside. The dividend goes on the inside. Then you went and saw how many times is 3 going to 3, and you said once. That's where you got the 1 from. Now, as far as taking it down and putting numbers, what do I write? What would I get underneath the 3? Another 3. Okay, because 1 times 3 is 3. And then I heard Brianne say, then a bunch of subtracting happens. And what's 3 minus 3? 0. And that's what you were trying to tell me without walking through the whole steps. Then what happens?
Then you move over to the next number.
So drop it down. And then I start over. How many times is 3 going to 4?
1.
So then therefore 1 times 3 again would be 3. Subtract them. I get 1. Drop to 7. So now, how many times? I keep doing it. It's the same process over and over again, right? Okay. How many times is 3 going to 17? 5. Which is 15. Subtract them. I get 2. 28. Now what? How many times does it go in there, Isaac?
16.
3 times 16 is 48. 9 times. 3 times 9 is what? 27. Now, this goes back to when you guys were first learning this in elementary school. And I know that for a fact because of my boys that are in that. And I know I've helped them with this. When you were first learning this, one of the things that your teacher had you do was you found the quotient, which is the top part, and then you put, one of the options you had was you put a big giant R with a 1. Do you guys remember writing R1? R, when it comes to upper level math, is all real numbers, not remainder. So therefore, to me, that looks like 1,159 are all real numbers, 1. So that's not R. It's not a remainder anymore. Another option that you guys had was to put decimals and keep going. If I said decimals were okay. What's a third alternative way of writing the answer as a remainder instead of using decimals and using the R? The quotient plus the remainder over the divisor. You've probably never written it like this or seen it like this, but you have seen this, 1159 and 1/3. Have you made a number into a mixed number before? Absolutely. The remainder was with the top number, yeah? Okay, that's what it was.
Not too long ago, you told us specifically to never do mixed fractions again.
I know. And that's why when I had the 1,159 and 1/3, I'm not even going to write it like this. I'm going to write my answers more like that. Here's why. Because now I'm going to give you a problem, and guess what? It's not going to be numbers. We're going to have letters now. Okay?
Math no longer includes numbers.
So, that process that you guys told me as far as how to divide it, great job. Now, you're going to actually divide ones with letters. X cubed minus 7x squared plus 6x plus 8 divided by x minus 1. This is how it's going to look rather than the previous problem. This is what it is, just like this. So let's get the setup done first. What piece goes on the outside? What's the divisor? X minus 1 goes on the outside. What goes on the inside? 3x cubed. Now, one thing that I want you to realize, and we're going to do this on the next problem, but one of the things I want you to realize is when Vanessa was telling me it, she told me all the numbers and she put it in order. Sometimes the problems are not in order. And what I mean by order is it should go highest exponent down to the constant. So what's the highest exponent for the inside? 3. So does it go 3, 2, 1 constant? Yeah. If a piece is missing, then what I would do is, like right now, Devin is gone today. I feel sad that he's not here. So therefore, I'm making sure no one is sitting here. So I'm holding his spot open for him. In math, to hold a spot open for you, you would put 0 and then whatever that exponent needed to be. So it'd be like 0x to the whatever, if it was missing. Okay, we'll do one like that here in just a second. Now, going back to what you guys said on the last one, you said 3 goes into 3 one time. Same concept. How many times, or what times x gives me 3x to the third? I didn't hear you. What times x gives me 3x to the third?
3x squared.
Very good. 3x squared. So I put 3x squared on the top. Now, what I was trying to get out of Vanessa earlier when she was trying to do it and she got lost in how to explain it, was then she took the 1 on the top times the 3 on the outside to get 3 underneath the other 3. Same concept here. You need to take the 3x squared times all this. What's 3x squared times x? 3x cubed. Very good. And then what's 3x squared times negative 1? Negative 3x squared. And then what did you do with in this problem back here? What did you do with the 3's after you got that? You subtracted. So we're going to subtract. Now, here's part of the problem. 3x to the third minus 3x to the third is what? 0. This goes bye-bye. That's gonzo. But negative 7x squared minus a negative 3x squared becomes what? Negative 7 plus 3.
Negative 4. Yeah.
So I would end up, you're confusing yourself. You're even confusing me when you're trying to say it, Isaac. So therefore, let me show you something a little bit different. When I was doing this, when I was your guys' age, the first thing that I would end up screwing up is if you screw up this middle one right here, right there, if you mess up that one, guess what happens to the rest of your problem? It's wrong, right? So therefore, here's something that I did when I was your age when I was doing this. I had to realize this, and I know it sounds corny when I say this, but that's the way it is, and that's the way I made it so that I could remember. I draw my line, switch my signs, add straight down. Subtracting is nothing more than switching the signs. So therefore, what is 3x squared cubed minus 3x cubed? 0. It's gone. What's negative 7x squared plus 3x squared? Negative 4x squared, which is what you guys got, or somebody got. I think, Sean, you said it. And then what do I do for long division? After I got that part, then I drop down the next piece and start over. Remember when I said it was just the repeating the process on the number one? So you guys, what times x gives me negative 4x squared? Negative 4x, good. Negative 4x times x is negative 4x squared. Negative 4x times negative 1 is positive 4x. Draw your line, switch your signs, add straight down. What happens with the squareds? What's negative 4x squared plus 4x squared? 0. Good. What's 6x minus 4x? 2x. Drop down the 8 and start over. What times x gives me 2x? 2. 2 times x is 2x. What's 2 times negative 1? Negative 2. Draw your line, switch your signs, add straight down. What happens with the 2 x's? They cancel out. What's 8 plus 2? 10. Can you multiply x by something to give you a 10? No. If the divisor, the number on the outside, has a higher exponent than what's left over, you're done. That leftover is the remainder. So remember what I just showed you about a different alternative way of writing the remainder? We're going to write it as plus 10 over x minus 1. Where's the x minus 1 from? The outside, the divisor. Right. So 3x squared minus 4x plus 2 is the quotient. 10 is the remainder. And x minus 1 would be the divisor. That's what you're doing today. Now, on page 177, you have 4 problems to do. So, Mr. Nick, would you pick a problem, either 5, 7, 9, or 10? 10? Yep. Okay, so there's number 10. First thing that we need to do is we need to set it up properly. What goes on the outside? What's the lead term for the inside? Bless you. 4x to the 4th. Now, if I have 4x to the 4th, I should go 4, 3, 2, 1, constant. Is there an x to the 3rd term in our problem that Nick chose? No. But there's going to be, so what I'm going to do is I'm going to leave a space open for the 3rd term. And here's what I do. No matter if I put 0 in front of a term like that, what's 0 times anything? 0. It's like it didn't exist. Like right now, even though I know Devin's gone, it's like he didn't exist, but I'm holding a spot open for him. Or Carrie's gone, so therefore I would hold a spot open for her. Now the next one over would be x squared. Is there an x squared term? No. So I'm going to put 0x squared in there. Is there an x term? Yeah. Plus 5x minus 4. Okay. Now, I set it up where I put zeros on the inside. Could it be where you have to put a 0 on the outside?
Yeah.
Yes, it could be. If I have x squared minus 1, for instance, I can put x squared plus 0x minus 1. So that way I keep the consistency. Okay, everybody got the setup okay? All right. What times x squared gives me 4x to the 4th? 4x squared. Very good. So 4x squared times x to the 4th is 4x to the 4th. 4x squared times negative 3x. What's 4x squared times negative 3x? Negative 12x cubed. Now, what I wanted you to see by that especially is the fact that if I didn't leave a space for that x cubed, where was it going to go? If you don't leave a space for it, you'd have no room for it. That's why you do that. What is 4x squared times negative 2? Negative 8x squared. Draw your line, switch your signs, add straight down. What happens with the 4x to the 4ths? They gone. What's 0x cubed plus 12x cubed? Very good. What is 0x squared plus 8x squared? Drop down the next term. And as you guys said on the number one, repeat the process. What times x squared gives me 12x to the 3rd? Yay, 12x. And then you multiply that by each piece. 12x times x squared. 12x to the 3rd. 12x times negative 3x is what? Negative 36x squared. 12x times negative 2. Negative 24x. Draw your line, switch your signs, add straight down. What happens with the 12x cubes? They cancel. Bum, 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 gone. What's 8x squared plus 36x squared? 44x squared. What is 5x plus 24x? 29x. Drop the negative 4 and start over. What times x squared gives me 44x squared? 44. Yay. 44 times x squared is 44x squared. Have you guys noticed that when you multiply for the leading term, it's always the same thing? Yeah, because when you subtract them, you want them to cancel. What's 44 times negative 3x? Negative 132 is correct. What is 44 times negative 2? Negative 88. Draw your line, switch your signs, add straight down. What happens with the 44x squareds? They cancel. What's 29x plus 132x? 161x. What's 88 minus 4? 84. Can I multiply something by x squared to give me 161x? No. What is all that stuff that's left over? What's the leftover known as? The remainder. Right. So, here's my final answer. 4x squared plus 12x plus 44 plus 161x plus 84 over x squared minus 3x minus 2. When you write that on the over part, remember it's just the remainder that gets written over the divisor, not the quotient. Okay? What do you think of the process? It is tedious. It is long. It's going to take up some paper, but that's why we only give you 4 of them. That's one of them. But the process itself, it repeated itself, didn't it?
Yeah.
Just like you did when you were back in elementary school. It just keeps repeating until you get down to the end. Okay? You have 4 of them to do. That's number 10, which is one of them. Okay? Hopefully we should have a lot of people turning this one in, since there's only 3 of them on your own. So on page 177, you're doing number 5, number 7, number 9, and number 10.